Hello from me, I'm Martin, I'm a co-founder in Bitcoin Goat and one of the board members. And okay, it's working. My name is Martin Kuvandzhiev and again, I'm co-founder in Bitcoin Goat. I'm founder in a pretty cool startup company in Bulgaria called Go Startups. And also I'm a CEO in Assetify, which is a very interesting project that I would like to have you hear about this soon. So I'm also a crypto and fintech consultant, and the thing that I'm proud the most that I play guitar. Also, I'm blues enthusiast. By the way, who is listening to reggae and ska here? Do you know Jada Cat? You must listen to Jada Cat. They're amazing and they're from Amsterdam. So what's Bitcoin Gold with really few words? It is a more decentralized version of Bitcoin, and it is an alternative. Our main feature is that Bitcoin Gold has almost the same structure as the Bitcoin chain, and up to block number 491409, if I recall correctly, the chain is the same. That means that if you at that moment had a certain amount of bitcoins, you're going to have the same amount of Bitcoin Gold in your wallet if you possess your private key. So we have made it GPU mineable. That means that only graphic cards can mine Bitcoin Gold. And also we have implemented replay protection. We have improved the difficulty adjustment algorithm, and it is, in my opinion, times better than the Bitcoin original difficulty adjustment algorithm. And mostly important, it is really decentralized. Our team is on 6 different continents. So I'm not going to speak more about Bitcoin Gold. I'm going to speak about vulnerabilities and attacks on the blockchain network. Next. Okay. So first of all, I'm going to speak really briefly about Eclipse Attack, breaking the cryptography, dropping transaction, and then I'm going to give more details about one of the most serious attacks in the blockchain world, and it is the 51% attack. So the Eclipse Attack is something really simple. We have one device, the green one, that for example wants to send a transaction to the network, but this transaction is being dropped, or this information is being dropped or changed by other devices that are surrounding it. It is not really easy to happen because it should be on a private network. For example, here, if we're using the same router, the same internet connection, and for example, if I want to send a transaction to some of you, but there are people that would like to make an Eclipse attack on me, they can drop this transaction or show it as sent, but as soon as this network connection is not working anymore, or the peer is going to outside network, he's going to see that this transaction actually has not passed to the real blockchain, to the real world. So this is one of the first attacks in the blockchain, and it is not that bad because it is really hard to happen, and it can happen only on really isolated places. Second, more likely to happen thing is breaking the cryptography. As we're having colleagues from IBM here, they can maybe speak you more about quantum computing and about the recent technologies that they're making in IBM, which are pretty cool, by the way. But with the quantum computing, actually the SHA-256 and ECDMA can be broken. These are the ways that the cryptography in Bitcoin works and uses for signing the transaction and for sending them. What it means if they are broken, that means that there is a possibility that someone knows your public key and they can start seeking really fast using quantum computing to find your private key. If this happens, in Bitcoin Gold we have a solution, and it is just changing the algorithm for making the cryptography to another, which is quantum computing safe. There are such algorithms, and there are big forums in the world that are being made every few years that are presenting more and more innovative and cool algorithms for doing the cryptography, because cryptography is something really important. And what is the possibility of brute forcing a private key? Brute forcing means that you try again and again and again and again until you match a certain private key with the public key. It means that for each person on this planet, there are 2.15 multiplied by 10 powered by 38 different addresses for each person, which is practically impossible to happen. Okay, dropping transactions, I actually have told you about in the Eclipse attack that can happen. That means that if we're having a private network, it can happen that a bad party can decide to start dropping transaction by a certain peer. Also, it can happen, for example, if in the Bitcoin Cash network, when we're having a majority of a company that is controlling the majority of the hash rate, can decide to isolate a certain address. That means, for example, if I'm using Bitcoin Cash network, and if some of the guys from, I'm just giving an example, by the way, Bitcoin Cash, and if some of the guys there decides that I should not be able to start sending transactions or to receive transactions, they can actually override the chain by dropping my own transactions. And this is kind of applying a censorship to the network. But this is again not that likely to happen. The thing that we're seeing as a trend in the last year, it is the 51% attacks. With the largest chains that have been attacked by this is Bitcoin Gold, Ethereum Classic, I forgot the name of the other. But yeah, how it works. First of all, in order to make a 51% attack, you need to have the majority of the hash rate of a certain network. How you can get the majority? First of all, when you're having more miners, more hash rate than the rest of the network. And how you can do this? By having the most miners, which is not likely to happen, or by renting a hash rate from services, for example, like NiceHash. For the attack on Bitcoin Gold, we have actually proven that this attack has happened through NiceHash. So NiceHash is kind of a centralized product in the centralized world, but this is something else to speak about. So you need to obtain more hash rate than the real chain. Then you must create a transaction for you to double spend. What does it mean? That means that when you're making transactions in the blockchain, all of these transactions are being chained one after another. I'm having an input, which is someone sending coins to me, and then from these coins I'm starting sending transactions. That means that step by step I can follow all the coins that have come to my address and that have went to other addresses. And at some point when I would like to make... Okay, this is working. Okay, now. When I decide to make a double spend transaction, first of all, on the public chain, I send a transaction TX6, for example, to an exchange, and I'm making a chain split, and I'm sending the same from the same input. I'm sending a transaction to, for example, one of other my wallets that I can have. And at the same time, as soon as I decide to make the chain split, we're having the public chain, which is the original, the right chain that is mining publicly, and I'm starting to mine my own private chain. Why I'm mining my own private chain? Because on the public chain I'm going to have this transaction. On my private chain, which is not right now being to the network, I'm going to have my transaction to my wallet. And this way I'm having from one input, I'm having two different outputs. And this one is still private again. So after my transaction on the public chain has been confirmed, for example, I have sent it to some exchange, they require 10 confirmations. That means that 10 blocks must pass until this transaction is confirmed. When this happens, I'm, for example, exchanging to other currency, and then I'm withdrawing to my wallet. As of this time, I'm going to have my private chain with more hash rate being faster than the original chain. And then what happens? I'm just connecting my miners, my chain, to the original chain. And there is something which is called reorganization. That means that the both chains have the same parameters, they have the same blocks, the same block heights almost. The private chain has more blocks mined. And when this happens, there can be only one chain that is real chain. And actually this is going to be the private chain because it has a higher blocks, more blocks mined. And in the current algorithms, including Bitcoin, Litecoin, Ethereum Classic, Bitcoin Gold, most of the proof of work algorithms, the chain which has more blocks is the right one. So that way I have made my 51% attack. And when I overwrite the public chain, my own chain, which includes the transaction to my own address, is actually overwriting the public chain. And that means that as soon as I have withdrawn the money, for example, from the exchange, I'm having my own money that I have initially lied to have sent to the exchange, and also I'm having the money that I have exchanged from the exchange again to my wallet. That means double spend. I have used the same transaction input to spend it twice on two different places. And as I have successfully made the 51% attack, I have actually doubled my money. Okay? So how do we fix this? This is a really cool question. I'm going to speak a bit about consensus. Do you know what is consensus? How many of you know what is consensus? How many of you know how it works in Bitcoin? Okay, what is this? How many people think that this is a doc? Now we're having a consensus, because all of us see that this is a doc, and they're evaluating that this is a doc. Okay, what is the answer to this? $132. Other answers? Okay. See, we're not having a consensus. I can hear a few different answers. In the cryptocurrencies, in the proof of work consensus algorithms, we're having all the different machines calculating the same equations. And at the end, if the mathematics is okay, all the answers should be correct. But that we see right now that we don't have a consensus. This is the right answer. If I say that this is the right answer, are you going to say that it is the right answer, or you're going to calculate it again? Yeah, you're going to calculate it again. This is how all the cryptocurrencies, like most of the major, not all of them, are working. Again, they're recalculating again and again the whole blockchain. When you're installing the Bitcoin node on your computer on a server, it is checking again the whole blockchain. It is making all the calculations again from the beginning. It has the input information about the transactions and the blocks, and it is verifying them block by block. That is why syncing is sometimes taking 3, 4, 5 days. So the majority of the nodes are validating the data, and if the data is verified by the majority, this is the true. Actually, this is also called democracy, because we're living in a democracy world. But what happens if you decide to conspire against me? And I have given you the right answer, but you say, no, it is not the right answer. Well, it is the same as the 51% attack. Because if you start spreading the word with the wrong answer, many people are going to follow you. And at this point, we need notarization. How many people will have went to notary in the last 5 years? Cool. Do you believe the notary? The government believes them, because the government has said these people are the one to verify if something is true, for example, if a document is true or not. And if these people are are scamming anyone, or they're making documents that are not correct, they're going to be sanctioned by the government. Well, in Bitcoin Gold, we have decided to make the so-called blockchain notarization and block notarization. What does this mean? That means that we're not going to rely only on the height of the chain, on how many blocks has been mined, because we see that this can happen in the 51% tax and in the double spend. We're also going, let me show the graphic. We're also going to notarize the chain, each block. Who is going to notarize it? It is not Bitcoin Gold. It can be any of you. The thing that you need to do is to use your public key to publish it on the Bitcoin Gold repo, and as soon as this public key has been sent to our client, you're going to be able to become a notary. And as soon as you see that some block is being mined on the public chain, you can use this block and notarize it on other chain. What means on other chain? If we're making the Bitcoin Gold chain the notarization chain, we can actually have people who are playing with our chain. It is not that secure. But think about this. We're having the Bitcoin blocks mined on the Bitcoin Gold chain. But we have these blocks notarized, for example, on the Ethereum chain, on the Litecoin chain, on the Bitcoin chain. And that way we're having a security. Because if someone wants to attack Bitcoin Gold with 51% attacks, he must also attack all of these three chains. For example, I'm giving just an example. It can work with most of the current cryptocurrency projects and blockchain projects. And when we see that this block is being notarized and this block, despite the fact that it is higher, it's not notarized, we can certainly distinguish which is the right chain that we should accept. Excuse me? What stops the attacker from notarizing the private chain himself? The attacker is mining privately, and the notarization happens by entities which are known. When we're having all of these people here in this room sending the same information to the other chains, notarizing the chain, the attacker is going to be just one person, but not the whole room. That is absolutely true for the CBO attack. You can make whatever amount of entities that are sending the same information with different addresses. And we have thought about this. That is why we're making our notarizations with exchanges who can notarize that they're using their wallets, and also with the pools. So we're going to see in the initial state of the chain who are the real entities that are doing this. Okay? No, not only exchanges. Exchanges, pools, people can start submitting addresses, and these public keys. And these public keys can be approved to go to our chain. Not a KYC. It is trusting the notary is by having, for example, you know which is the Bittrex address, you know which is the address for the mining pools. You have seen these addresses because you see them mining on the chain. And for example, when you send your transaction, it can go to one of your addresses on the exchange, and then this address is sending the transaction to their hot wallet or their cold wallet. And for example, we know that Bittrex, when they have worked with Bitcoin Gold, they have something like 5 different Bitcoin Gold addresses. And we see all of these addresses on the blockchain, and we know that Bittrex is owning these addresses. And that is how it can happen. It is not centralized. It is centralized if we're trusting only us, in my opinion. We're all discussing this because it has not been still implemented in Bitcoin Gold, and we need to change the world of the 51% attacks. Proof of work has this vulnerability. And at some point we must find our consensus on the way that we're going to approve which block is correct and which block is not correct. We are all trusting at some point the exchanges. We're all trusting the mining pools. Right? In practice we do. Because there is no other way. I agree that we don't need centralized exchanges. Actually, one of the projects that I'm contributing recently is a decentralized exchange in Bulgaria called Wadex. Because they're doing pretty cool stuff. And they're making an amazing cross-chain transactions using atomic swaps and stuff. But again, at some point, if you want to have a secure chain with using proof of work, and you have the way to make the CBO attacks, 51% attacks and stuff, you need to find the right algorithm that can do this notarization. And if we see this notarization is being applied only when we're having another chain that is trying to make a reorganization. Yeah.
So the whole innovation of Bitcoin and crypto is that you don't necessarily need to trust the miners. The whole thing is that you have this sort of economic finality, or that there's this amount of economic resources that are being put behind a certain truth or state, and that to dislodge that truth, you need to control a significant amount of money or wealth in order to disrupt it. And that's the whole essence of blockchain. And it doesn't
The whole thing is to participate in the blockchain, right? To participate in the decentralization. And you can do this, actually, you used to be able to do this in Bitcoin by having your own miner. But right now, as many of us may know, more than 50% of the hashing power comes from China and from the Bitmain factories. Then can you trust the Bitcoin blockchain?
I think you can in a certain way, because if an attacker needs to control this, it still costs a significant amount of money to control this amount of hash power, because the amount of hash power is so fast that even like, I'd have to trust the miners, I guess. But if the people who control all this infrastructure use it to disrupt the blockchain, they'll destroy its value, and they are they have a lot of stake in the value of this network itself, so they'd be destroying their own assets in order to disrupt it.
Yeah, you're stating that, I don't know if all the people here, but you're stating that if these people who are controlling the majority of the hashing power needs this chain to work, this system to work, they are not going to destroy it by making a 51% attack, for example. But okay, we have seen, for example, Bitcoin Cash, which is stating to be the real Bitcoin. And we know that these people are actually having a lot of hashing power. We have seen it during the split of Bitcoin Cash Roger Ver version and Bitcoin Cash SV/Fake Toshi version. And we have seen how much of the hashing power from Bitcoin.com went from Bitcoin to Bitcoin Cash Roger Ver version. And this has been made by just sending a message. We're just translating your hashing power, don't worry. Have you seen this?
Yes.
So you see how we're having a centralization in something that should be decentralized. And that shows how someone can just start playing with the hashing power by just transmitting the hashing power from one place to another. And you're saying that these people should care about the Bitcoin. But then we're seeing that they're attacking the Bitcoin, saying that the Bitcoin guys, the Bitcoin core developers are the bad guys in this picture. And they can at any point of time decide just to make 151% attack and to say, see, it happens to Bitcoin. But in Bitcoin Cash, this is not going to happen, because this can be a really good marketing for them at some point. Actually, that was one of the reasons why we have created Bitcoin Gold, because all the mining process should be made by the peers of the network. They should be also able to control the nodes. And in our opinion, they should be also able to notarize the chain.
But then again, with the notarization process, the same thing you're doing is you're just leveraging the finality of other chains onto your chain. So it's still, you add some kind of safety, but the safety you add is effectively the safety that other chains have. You can't go to a higher level of security than whatever the highest level of security that. So it's added to security.
Yeah.
The hashing power of all the chains together. You would need 51% of all the chains.
The attacker needs to, for example, make 51% not only to Bitcoin Gold, but also to Ethereum, to, for example, Bitcoin, and to Litecoin, which is a lot of money. Right now, the 51% attacks costs, for example, between 1,000 and 20,000 US dollars per hour. But this is only for one chain. And this, if they want to make a 51% attack on all of these chains, it is going to be really, really hard. In my opinion, it's going to be practically impossible.
Yeah.
Yes?
Can I ask a question? So would it then cost more than it costs now? More security, would you tend to add more fees?
Yeah, it adds a lot more security when you're notarizing your own chain on few other chains.
You have TX costs.
You have TX costs, yeah. That is actually when you're making a CBO attack, it is going not to be cost worthy at some point. Because if we use, for example, Bitcoin and Ethereum network, you're going to have to spend a lot of money in order to notarize more than exchanges, mining pools, and peers that want to contribute. Okay. How does this sound to you? Does it look like a viable solution?
Like the question I have is with the private chain issue, like with this attack vector, the problem is that you have a whole series of chain with a certain number of blocks that aren't getting publicized and broadcasted publicly. Like I'm not totally sure that you need to have a certain set of people that are saying, stamp, I approve this block. Like I think there may be some other way as far as saying, okay, if you have a series of large number of transactions that are not being publicly broadcasted to the majority of the network, or even something, say, more than 51%.
But again, this can happen with this kind of CBO attack when you spam the network with transaction. Like you can spam. Yeah, from what I hear from you, it is that you're asking if, for example, this cannot happen other way. For example, like counting the number of transactions on the private chain and on the public chain during a 51%, and if this can help. Because we're supposing that on the public chain, you're going to have more transactions than on the private chain, right?
Not exactly. Like my question was, basically the issue that you have there is that someone in private with a lot of hashing power is creating a lot of blocks and not broadcasting them over the open internet to the rest of the network. And so then someone shows up with a bunch of blocks that have not been previously broadcast on the public network. And just the fact that they haven't been distributed on the public internet could also be possibly a way of identifying this type of side chain, private chain that's being done, apart from having a centralized whitelist of groups that are stamping each of those blocks on the public chain.
Yeah, that's true, but in your solution, this is like counting the different timestamps on the blocks, right? For example. And that way we can understand if some of the blocks has been beamed or not. But this is not a sustainable way to count it. Because we're having like, even if you're having a watch which is in the US and another watch which is, for example, in Bulgaria, and you have synced these watches 1 year ago, we're going to have seconds, maybe minutes differences between these watches. So having the timestamps is not a sustainable method of determining which is the right chain.
It's also you're looking at observable blocks. So if I was a node, I would say, okay, I got all these blocks, and now all of a sudden, here's 100 blocks that I haven't seen before, and I only have 90 from the chain I've been working on. So then there's the reorganization. But if I just said, okay, these 90 I got over the last bit of time, and these 100 came all at once, I'm going to disregard those. What you're creating is auto forking. You're not creating a single chain. The chain would just fork, and that less than 51% that's being attacked would create a fork.
At the individual node level, but at the aggregate for the entire network?
No, all the nodes that were innocent that received those 90 blocks would continue to fork in theory.
But at the point when it's privately mining a separate chain, you already have a fork. It just is whether or not everyone accepts it.
But then they merge it back. That's the attack.
No, that I understand. But okay, maybe also better over years later.
Auto forking chains.
No.
Martin, are you done with your presentation? So
Yes.
we can do some other questions on the audience, or?
Yeah, we can do some other questions. Cool. Okay, other questions?
Are there any more questions on the back? Yeah.
So, about 50% I understood and 50% was above my head. This is a concept which you're presenting, right? Which could potentially help with the 51 attack.
Yes, this is
Yeah.
a concept.
So, at the moment, to do an attack in Bitcoin Gold, you have, the total value is about 120 million or something like that, or 200 million is Bitcoin Gold. How much would it cost me? You say it's 10,000 euro per hour to buy the computing power, and then I could basically rearrange your Bitcoin Gold for that in an hour time, or how vulnerable is it at the moment?
I must check how vulnerable it is at the moment, because until 2 weeks ago we have been completely vulnerable because NiceHash did not have the Equihash BTG, which is our custom algorithm for mining, on their marketplace. But as of that moment they have it, and we have an automated reporting system that sends a message to all of the Bitcoin board and some of the other people in our community to say that at this point we are maybe at a 51% attack, and we're evaluating the hashing rate on all the pools that we know that are mining Bitcoin Gold. And if we see that we're having
Yeah.
this hashing power
What do? You
sent
close
to
it down?
other place,
Yeah.
we are just sending a message to the exchange with be careful, we may be under a 51% attack.
And so they
Do
have to
not
stop
approve.
trading? They have to stop trading for
Not
that?
stop trading. They should stop the transactions which are with higher value. Because, for example, when you're making a 51% attack that is worth 10k euro, for example, then you're making a transaction which is at least 100k. And when the exchanges see such transaction, they should consider it and make a bit more.
Okay, so this is an extreme non-decentralized solution. I
It
mean,
is
you're
completely
And so then
non-decentralized.
the next follow-up question is, how much would it be for Bitcoin Cash or for Bitcoin, Bitcoin itself, or how many other chains are into attack, are easy to attack with that kind of money?
There was a really interesting site which was about the 51% attacks. If you see in the internet 51% attack cost, it is showing what is going to be the cost to attack a certain chain. And we can see that projects in the top 50 in the cryptocurrency networks can be attacked for something like $500 per hour, which means that you can hold them in like 5 days non-stop attacks with the different exchanges. Do we have time for one more question?
Yeah, sure.
Okay.
Last question.
Hi. Everyone is focusing on the attacks of the network on the just to duplicate a Bitcoin. But look from the miner's perspective. If you are a miner, for example, I'm just a single miner alone, have a small capacity, suddenly I find hash and big miner finds it as well, then I will not get any. There is a possibility that I might not get reward, right? So
Yep.
this is the biggest problem in this respect. How does it solve?
All of this, like your question is, for example, when you're a small miner and by chance you find a block at the same time when other big miner has found a block.
That's a reason also to pool, to create a big pools and to get a.
Yeah, this is one of the reasons, and how this is solvable. In Bitcoin Gold, we're keeping a 10 minutes block time, and also we're having a dynamically adjusted difficulty algorithm. What does it mean? It means that once every 600 seconds there should be a block found, and this is kind of really like we have seen something like 15 or 20 organizations in our chain for the last year. That means that there has been block found on the same time, but it is really hard to happen because we have large block time, like large. We need 600 seconds on average from one block to another. In Ethereum, you see that they're having 15 seconds actually between the blocks, and this happens a lot in the Ethereum network. And what they have done is to make the so-called uncles, which are giving half their worth, I think it was, for the block to the one that have found an uncle block. So yeah, to summarize, in Bitcoin Gold network, 600 seconds between the blocks is a time which is considered as enough to make sure that there are the blocks that are being found consequently and there are not that many reorganizations. In Ethereum, there are reorganization done maybe every 10 minutes. Okay, you can follow me. Oh, they have changed the laptop. Okay, you cannot see where you can follow me. If you have any questions, you can go and find Bitcoin Gold in Facebook, in Twitter, or whatever. Just drop a message, write it is to Martin, and they're going to send it to me. Thank you for the nice question, for the attention, and for being here tonight.